Okay, so I've recreated a board using the board wizard again. Um, this is roughly 5 inches by 5 inches, and I've gone ahead and put these. I actually increased this both to 1 millimeter and then 2 millimeters. Again, this is the gray is the edge of the board, the orange is where you have to keep the routing in, and then the purple is the actual um, where you have to keep the packages inside of. And then I went ahead, here I'll just exit out of this, just to remind you, I went ahead and went to place components manually, and then I select all, and you can kind of see some of the pictures there. And now you can see there's plenty of room to put them in the board. Again, sometimes people put them outside the board. I'll go ahead and just randomly put them in the board for now. And now I created a board that is obsessively large at this point, way larger than we need. Um, and so I'm not going to necessarily worry about the fact that it's larger than I need. In reality, whenever you're doing a board design, you are most likely going to have constraints on the size of the board based off of, well, what's the size of the container that it's being put into, um, or what is it being connected to. So, there will be board constraints typically as far as the size of the board. But for our purposes, we can just kind of create a board for now that's big enough to have all of the components on it. And then once it's big enough to have all of the components on it, we will be able to just simply have those there. Now I'm going to go ahead, as I said, and zoom in a little bit here so we can see this. This right here is what's called, again, a rat's nest, because it's literally just showing the components all connected up together. It's not actually showing, it's showing the linkages, I should say, but it's not showing how anything is connected up. Things aren't necessarily in the best optimal position. And so you can go ahead and close this window, but I find it harder to select and move sometimes when it's closed. I mean, like right now, I'm very able to select and move, but right there, oh wait, I started putting a trace down, and I don't really want to do that, which honestly I find this funny. I'm right clicking here, is that there's this oops button. Like, oh, I don't want to do that. So what I like to do is keep this clicking somewhere off the screen. I like to keep this place component up here because then the only thing I can do is pick up and move components at this point. And so that's what we're going to do. Now, um, we are going to actually look at this chip here and look at the data sheet for it because we have some requirements that might be needed for this data sheet here. And I don't remember why I have three capacitors here. Oh yeah, because one's on the output there. Okay, so this is my circuit diagram, which often, again, you might want to refer back to, but I'm going to open up a web page here, and this is a 741 data sheet. So I'm going to pull that up here. And again, there's so much that we have to kind of keep track of in a data sheet. Well, what are we doing now? We are doing a layout. So look, there's a layout here. Now, not all data sheets have this for every component, but for ICs, there's often this for an IC chip. And so this is a layout guideline. It says, as with most amplifier, take care with lead dress, component placement, and supply decoupling in order to ensure stability. For example, resistors from the output to the input should be placed with the body close to the input to minimize pickup and maximize the frequency of the feedback pole by minimizing the capacitance from the input to ground. Okay, so it's saying a lot of words there. A lot of words that I don't necessarily understand everything. But what you can see is you can see how these things are traced as far as this component. And so this R2 and R1 are literally these two resistors here. is what they're trying to do with an example. And then they're saying there's an input. Now we have another resistor on the input. I'm not going to go into an explanation of why I put that in there, but that is a good practice to actually have another resistor there. And again, can tell you why later on if you're really interested in that. And then it has these capacitors here. Now, I know because I've done this chip so many times that this pin right here is the negative power supply, pin 4, and that pin 7 is the positive power supply. You can also see that from the schematic here. And these capacitors here are decoupling capacitors. They're supply decoupling capacitors. And those are these two capacitors right here in the circuit diagram. And this here has like a little hole here, but this is actually representing that it's going to ground. It's not a good indication here. This is also going to ground, just like this one is here. And this is also going to ground, just like both of those are here. Now, again, the reason for that is honestly, it's to supply stability to this. But an easy way to think of it is, again, if you're switching this op amp from a negative voltage to a positive voltage quickly at high frequencies, you need kind of a storage tank of energy, of charge, to be able to do that switching that fast. Which, if you can't do it that fast, that's what puts in more instability within the design. Now, these are also, as you can see here, these resistors here, there's no holes associated with them. These are square landing pads here. Like this is a hole right here. This is assuming that they were what are called surface mount resistors. But it doesn't matter that we're not using surface mount resistors. We can still do the same thing. We just need to account for the fact that they're not surface mount. So why don't I open this here, and what I'm going to do actually is I'm going to shrink this here. Maybe that's not a good idea. We'll see if we can get this to work here. Let me do this. There we go. Increase this because I don't want to close this window because we're going to use that. Whoops, I'm in the wrong window. Yeah. So if you, whoops, whoa, I just got the weird zooming. Can't remember. There's a way to, can't remember what it is. There's a way to drag the screen around, but I'm just doing, I scroll to zoom in and zoom out, but depending on where your cursor is, you can see it zooms in and zooms out differently. Okay, so this is good enough for what I want to do here. And again, I want to bring up this little diagram here. So, and I'm going to just move this down here for now so that we can see all of these things together. So I'm going to just kind of place this IC chip here for right now. Notice they also have a square pin here as well to kind of indicate pin 1. And as a side note, that little circle there, that's a fiducial. So the R2 and R1, well, we need to see what are those called in my circuit. Well, they're actually flip-flopped here. R2 is the one that in this, let me bring it up side to side here. I have them flip-flopped. Now this R1 is actually R2 here. This R2 here is R1. Now that is irrelevant. Doesn't matter. They're not the same name. That's fine. But we need to account for that when we're doing our layout here, if we're trying to do a layout like this. And so I'm going to go back to my layout here. And so I'm going to look now for R2, which is my R1, and you can see it's right there. And I'm going to go ahead and have it like it was, where it was kind of horizontal there like that. And I'm going to move this off to the side here because I don't want to get this in the way. And then I'm also going to say, well, this is the other one here. And it had it going vertically. So I will go ahead and I have it selected. I'm moving it around. And if you right click, there's an option here that you can rotate. And so you can rotate this around and you can kind of see like how you could do different ways to rotate. I wouldn't want to rotate it like this because I'll zoom in here because you can see how the rat's nest doesn't look very good. There's this line here that's going all the way, well, I just put all the way across that bottom pin all the way to the top. But if I rotate it back like this, oh, that looks much better as far as the way the lines are connected. So I'll place it like this then. And then it's needing those capacitors. Well, it's saying C1 and C2, but again, I need to see what they are on my circuit diagram. So it's actually C2 and C3. So C2 is the one that's on the positive, which is pin 7, and C3 is the one that's on the negative, which is pin 4. So let's go here, and let's bring this back up. So I want to find C3, which is on the negative one here, and I'm going to go ahead and again kind of look at how it's located here, and I'm going to see that, well, wait a minute, I might want to rotate this and have it rotated so that it's like this, lining up with the power supply like that. And then this is where, again, I zoomed out incorrectly there. Okay, then C2 is the one that's on the positive power supply. So that one can kind of get put over here because, again, we're trying to keep it close to the chip. And maybe we even move this one a little bit closer. I'm going to move this one up just because there's clearly a pin 7 here. Now it looks like you still have messiness with the rat's nest, and it's not that the rat's nest is going to be perfect. And then this is our power input. So again, you want to put this somewhere where it makes sense, and so we're going to have kind of looks like putting it down here might clean up the rat's nest a little bit. And then the remaining things here, well, we've got this one is on the input as well. Oh, well, wait a minute. With where this capacitor is and where this is connected, well, first let me rotate this so that I can get this little bit of a rat's nest a little bit better here. You'll see now there's that little red thing because the components are placed on top of each other. So I'm going to move that one away again, kind of put this one in here, but then I want to still keep this close because, again, this is for this power supply right here. And so I'm going to put this here at the top because this will be my input and output. The bottom one is my power. Now, why am I putting it at the top versus the bottom? There's not necessarily a reason for that. That's just my choice. So this particular one here, this is where sometimes also going back to the diagram can help. Okay, that's on the output and ground, but look, there's this capacitor that comes in first, C1. Okay, so let's move this C1 here, and that's really going to be on the output here, and you can see how that changes over to here. And I'll go ahead and rotate this to be like that. And so this is a pretty decent rat's denesting. Now, I'm zoomed it back or increased my screen completely. So it's not a perfect rat's nest, but it's pretty good. And so I'm going to go ahead and save my file. It's always important to save these often. And now I'm honestly ready to route the circuit. Now there is a way to do automatic routing, but honestly, automatic routing is often not done because some of the automated routing doesn't really work very well. And so there is a lot of stuff that's still hand routed. And so to do the routing, well, first off, I need to make sure I closed out my components. So you had to place, you need to make sure that's closed out. So I'm down right here. Then I'm going to go to route and connect. Now, because I have two layers here, um, it is going to have the ability to route on either side of those layers, on the top or the bottom. Now, this is why I like to have two-layer boards, because by default, if you only have one layer, it's the top. And you don't always want that because, again, for through-hole components, we solder everything from the bottom side. Now, let me kind of show you. I'm not going to actually route anything. I just started clicking randomly, and so this green trace, I left-clicked randomly. This green trace is now on the top side of the board. Now, if I double-click, I've actually now transitioned to the bottom side, and what it's done here, and I'll double-click again, and then I'll end this. Now, this is completely useless, but what it's done here, whoops, is it's actually, when you double click, it creates a via. See, that's a via right there, and that's a via right there. And so that's actually creating those vias to go from the top side and the bottom side. But we don't want to have any of those things because we are going to wire everything. This is a simple enough design. We should be able to route this on one layer, and it's going to all be on the bottom side. Now, I want to delete these. So there's a couple neat little things here. If I right click off to the side here, there's some different kinds of things. There's this application mode, and one is etch edit. So that would mean that you're in doing just the etches. But another thing here are the super filters, which these super filters are kind of nice. I can do C-line segment. And so what I can do, the nice thing about that is if I try and select everything, the only thing it's going to let me select are those etch layers. So it's not letting me select any of the components. And then I can just simply delete those. Now the problem is I didn't delete these vias because these aren't etches, those are vias. So that's the downside to the super filters, and so I'm going to turn that off, select those, and delete. So it's not necessary to use the super filter, but I just like to show people that. So let's go back here and get back to doing our routing. So the reality is it's saying you're going to be on the top side, and then if you double click, you'll go to the bottom side. I really want to be on the bottom side, and quite frankly, I don't want to even go to the top side, so I'll just leave that on the bottom side. Now, there's this line lock here where you can say line or arc, and line lock for 45 means that it will have a 45-degree angle. So let me show you what I mean by that. See, whenever I move to the right or to the left, there's a 45-degree angle. If you turn that off, you can have it be, any which way. Or you can make it 90 degrees, which honestly are typically not done. 45 are pretty standard ones. I've actually not played with the arc before. Oh, so you can make arcs. Okay, interesting. I usually just do the line here. And then the line width here, you can, set it to be more than just, 1 times it if you want it to be thicker. But we're just going to do the 1 times line width. So I'm going to go oops here because that's not how we actually are doing it. I just wanted to show you what those features were. So to actually start routing is really playing connect the dots, and I'm not exaggerating. Let's just do an easy one here. You can see this blue wire is connected to here. So let's just go ahead and make that connection. Oh, and then this one is connected to here. Now you see, notice how it automatically said, I want to go down here instead. But suppose I wanted it to be at the top. So I could click here, but because of my grid, I have to go up to a particular way. Now what happens is by default, it's not going to let me break my line rules. So my ones that I've set. So if I click here, it's going to be fine here. Just like if I try and click here, and you can see if I press down, it moves the trace because that design rule we set of 0.5 millimeters line to line is saying that, hey, those traces have to be 0.5 millimeters away. I'm going to do an oops on that. Now, we don't have to, do something outrageous like that. You want to really keep things as tidy as possible. So I'm going to go ahead and just route a couple things that are, in my opinion, a little bit obvious connections together. Okay. Now this one here, we want to make sure that this is connected up to here. You don't want to go from the power supply. The whole point is that the capacitor is being connected into it. So the power supply is also being connected up. So you could connect it up to here, or you could connect it up to like the wire there. So you don't have to go dot to dot. You can connect it up to the wire. And notice that what will happen here is as you're connecting things that get connected together. So let's do another one here. So this is connected here. Now if I click here, it's saying, okay, you can connect it down to this hole, but also any of these things are fine as well because it highlights everything that's on the same line. So we can see that some more here as we continue to do our routing here. See, so it's saying, oh, well, this R1 has to go to the output. And remember the way that the layout has, it had it going kind of down the middle of the chip there. Then this was connected up to the output. And now I'm just again playing kind of connect the dots here. And this one here, okay, well, it's connected over here, but well, let's just think about, whoops, I just zoomed all the way over everywhere. Display, zoom, fit. That's not what I want. Display, zoom. All right. If you hold, there's supposed to be a way to just zoom into that particular window. Oh, whoa. I don't know what I just did, but I need to cancel that. All right, let me zoom back in here. All right, that's good. Okay, so this one, as I said, it's connected to this, which is actually ground. But sometimes, you don't want to have it do it automatically. So I'm going to say, okay, I'm going to go down here, but then I want it to go down a little bit further, and then I'm going to bring it up and in. And then this one here, I'm just going to bring up, trace over there. This one, trace like that. And this is to the output. Now you can see here, oh, I could try and go through this capacitor area, but that's not going to be a good idea because you can see it's trying to let me, but it's if I even click there, oh, look at all those errors I get because, it's trying to squish it in there, but it's not. Now you could say, oh, I could use a thinner line width. You could, but in general, you don't really want to try and go between pins like this. It can really just lend to problems for it. So instead, I'm going to click here and then just go like that. All right, and now we have a couple more that we have to connect up. And so this ground has to be connected to the same ground as there. Now, it also needs to be connected up here. So you see now I could connect it up into here. And what's nice is that by connecting it up into here, as I said, notice how these traces are kind of automatically spacing themselves for me. So I'll just go ahead and connect it right there. Now this is again where sometimes you have to think about, well, the line is the shortest distance, but that's not necessarily going to be the best way to go. And you can also see why having ground planes can make sense, because this trace here, it's 0, which that means that's ground. And so connecting all these grounds up, you're seeing we're having to kind of go all over the place here. And to connect that ground up, I could try and go through the middle of the circuit, but what makes the most sense to me is that I'm going to come up and kind of follow this one around. And actually I'm going to come in on the bottom side here and connect up just that way. And then we have this connection to be made right here. And now we just have one connection left to be made. And I got to get it up into here somehow. Now that one does not seem like an obvious one to get because of the way the circuit is currently laid out and lined up, because I got to get that to the output somehow. And actually that looks like it's in the wrong location here. To me, oh, yeah, that seems like it's connecting up to the wrong thing there. Did I make a mistake on my drawing here? Oh, this is positive voltage. It's not output. That's the problem. I was looking at the wrong thing. That's why having these labeled is, I thought this was the output. This is a positive voltage. And so I'm trying to get this up to either this capacitor up there or to that little input dot there. And so again, trying to get it through here is not looking like it's an easy thing to do. Now this is going to kind of, I'm going to break the rule that I said that we typically don't like to do. I'm going to actually do something here, and I'm going to get a design error on this, is I'm going to then change my width here. So I right click on my trace, and I'm going to do, or actually no, it's not there. I'm going to left click, and then what I'm going to do is I'm going to change the line width here, and I'm going to go to 0.5, which makes it much smaller line width now, and it's giving me an error. See all those little red triangles? Because I am breaking a design rule. I said that the minimum line width has to be 1 millimeter, and I'm breaking a design rule. But now I've gotten it connected up, and now we have to, and again, I know I just said that we shouldn't do this here, but based off of the way I laid the components out, and that's not to say this was the most ideal way to lay the components out, maybe it would have made more sense. In fact, honestly, here I can fix, I think I could fix it. Well, it might have made more sense to put the power jumper, up here, or turn it right and have it vertically along the side. I mean, there's a lot of other ways we could have laid this out to avoid having that thin line there, and that's why there's all of those little design rule tricks here. So, but we are at this point done with the routing here. Now you can see this little DRC that says a design rule check. That's saying we haven't, done either we're failing them or we haven't checked them. So if I do a DRC update, it's going to say that there's yellow here. And the yellow means is that basically there are some design rules that have um, quote um, been failed, but they're not ones that would prevent um, the production of the board. And so you can go in here though, and you can see it says odd line segment here. Vernal line segment width is 0.5. You know, width is 0.5. So you can see kind of where these design rule violations are coming from. I'm going to go to General Edit. See, it says DRC error, minimum neck width. It says constraint value is 1 millimeter, actual value is 0.5. So you could change your design rule, or you can actually waive the design rule saying, you know, this is okay. I mean, that wouldn't be a real reason you would waive it, but you can then actually waive those design rules as well if you want to. Okay, so then we've actually done our etch, our layout and everything. I'm going to end the video here, and then the next video here I'm going to show you how you would actually then get this prepped to actually then go on the machine to etch a board for this, and also show you a couple other things with this as far as if you were to prepare a board for it.